No, now it's recording. Okay. Okay. Let me know if you see Antalarico. Let me see if you see the whiteboard. Wow, I like that. Okay. Oof. Whiteboard. There you go. Do you see the whiteboard?
Yes.
Yes.
Okay, super. This is the first page of the review package. Let's do it one by one. No? Any question you ask me. The thinking you don't understand, but we are doing fast because somehow I suppose you know that, right? Okay. Okay, ready? We are ready to start? Okay, let's move on to question number one. Question number one is super easy because one system of equation is given and you need to verify if the solution is given a solution or not of the system. So one possibility is, pero too long, no. Solve the system and compare. Another solution is substitution one by one in the one by one equation and verify it is true. The solution is proposed is x equal 3, y equal 2, and c equal -1. I suppose you see very well the whiteboard, yes or no? Yes?
Yes.
Okay, good. Now plugging in the first equation. The first equation say is x plus y plus c equal 4. Just plugging in. X is 3 plus y is 2 plus z is -1. Be careful with the sign. It should be I claim that 4. It's obvious it's true because 3 plus 2 is 5 and 5 minus 1 is 4. Okay. At least this equation satisfies this solution. Let's move on to the second equation. See, at least one equation is false, there's no solution. So to be solution is maybe it's true in the 3 equation. So the second equation is x minus y plus 5c equal 12. X is 3 minus y is 2 plus 5 times -1 should be 12. This is 1, and this is together -5 is -4, and -4 is not equal positive 12. This is completely false. The solution then is, or the answer is, this solution is no solution of this system. It's another solution. Okay, I don't care because the problem is only verify this. Clear?
Yes.
Okay, super.
Yes.
Okay. Question 2. Question 2 is super easy because you need to solve the system. But by the way, this system is expressed like echelon, no? Because some variable equation are missing. For example, in the second equation, y is missing. In the last equation, x and y is missing. So actually, I know that z is -2. So you apply back substitution. Because the system is expressed in echelon, no? Echelon is something like that, like stairs. Entonces, si es -2, I know. I substitution this in the second equation, 1, 2, 3. 5y plus 3 times negative 2, because you replace c for negative 2 equal 4. 5y minus 6 equal 4. 5y is equal 4 plus 16. And finally, divided by 5, y is 2. Now, I'm going to find the value of the x using the first equation. X plus 4 times y, que es 2, plus 2 times negative 2, que es z, equal 3. This is 8, this is 4, minus 4, of course, this is 3. Entonces 8 minus 4 is 4, positive 4. X is equal 3 minus 4, x is equal negative 1. Entonces the solution is the triple order, negative 1, positive 2, negative 2, que corresponde with the option A. But it's not important because in the test we have no multiple choice, no? You show me a word in detail, that's it. Any question, guys? Back substitution. So one problem of the back substitution you can see in the test. Question? No? Sure? This is the moment to ask me any minimum question. Okay. Next question is number 3, no? Is a system, look, x plus y plus c equal 10, equation 1, x minus y plus 3c equal 14. Equation 2, and the third equation is 2x plus 2y plus 2c equal 12. Does you see any coefficients in the third equation? The last equation is even 2 and 12 divided by 2. If you divide by 2 the entire equation 3, okay, we can do the same. It's equivalent. It's x plus y plus c equals 6, because 12 divided by 2 is 6. And obviously this equation and this equation have a contradiction, no? Because x plus y plus c is equal to 10, and the same thing, it should be the same value, is 6. So when this situation happens, no solution. No solution, case inconsistent, option B. Super good. So one problem similar to this you see in the test. Okay, without do matrix, no. So look in the equations, you can find case inconsistent. No? Every question. Everyone follow me, yes or no?
Yes, it's clear.
Okay. Now let's practice a little bit partial fraction decomposition. Okay, so one application of the system. Okay. Number 4. Number 4, say. Okay, x minus 6 divided by x minus 2, x minus 4. You write the partial fraction decomposition for the rational expression. And we have two expressions because we have two factors in the denominator. And by the way, this factor is non-repeated, it's different. And you put a, b. Okay, now you multiply the entire expression by the LCD. The LCD obviously is x minus 2 times x minus 4, no? Both factors. When you multiply this, you have x minus 6 only, because obviously x minus 2 is cancelled with that, and x minus 4 is exactly the same, and a times x minus 4 plus b times x minus 2. So far, everyone follow me, or no? So far, everyone follow me.
Yes.
Entonces now you apply the method of the smart value, que es easier. It's easy fundamentally when you have no repeated real linear factors. Suppose you put let x equal 4. You have 4 minus 6 is equal, and this is cancelled 0, because 4 minus 4 is 0, and stay alive b 4 minus 2. Entonces 4 minus 6 es negative 2, 4 minus 2 is positive 2. It's obvious que b is negative 1 when you divide by 2, no? Both sides. Likewise, you are doing let x equal 2. Entonces, plugging in here again in the original expression, this one. X 2 minus 6 is equal a 2 minus 4, and that part gets cancelled because 2 minus 2 is 0. This is negative 4, and this is negative 2. Divided by negative 2 both sides. So the a is 2 positive. A is 2, b is negative 1. The partial fraction decomposition, so a is 2, b is negative 1. You can write like that. 2 over x minus 2 plus negative 1 over x minus 4. Or if you want, you can, for example, this negative you put here is the same. Either way. So one easy example like that you can see in the test. No complicated. Now, and this corresponds with the option C in the package. Now let me see, option C. Yeah, that one. Okay, how about let's do one more. You have no question. It's clear. Everything is clear. Partial fraction decomposition is clear for you.
Clear.
Okay. Okay. Number 5. Number 5 say 4 x squared minus x minus 13 divided by x times x plus 1 times x minus 1. Okay. Actually, we have 3 factors. 1, 2, and 3 factors. Okay. Now you separate, and the factor is not repeated, it's different. This is x, this is x plus 1, it doesn't matter, the order is not important. You put the order, and you associate letter ABC. Es obvio que the least common denominator is x times x plus 1, x minus 1. When you multiply then this equation by the least common denominator stay alike only for x squared minus x minus 13, because everything at the bottom is cancelled. A times, the rest gets missing here. Entonces, x plus 1, x minus 1, because obviously this x and this x is cancelled, no? No? Wow. This x and this x is cancelled. B times 1x, x plus 1, x minus 1, sorry. And C. X times x plus 1. Beautiful. Okay. Well, super fantastic value is 0. Because 0, you make 0, x equals 0. This is gone. And this is gone. I stay allowed A. And this is negative 13. Because this is 0, this is 0. And we have here 0 plus 1, que es 1. And 0 minus 1 is negative 1. So multiplication is negative 8. Therefore, A is 13. Boom, 13. Okay, let's do x equal 1. This 1 is different because this is 4, 1 squared. Obviously is 1 times 4 is 4. That's 4 minus 1 minus 13. Okay, 4 minus 1 is 3. 3 minus 13 is negative 10. The answer is negative 10. Entonces, what is cancelled? Well, this is cancelled. It's obvious because 1 minus 1 is 0. This is cancelled again, but this no. So the C part stay. This is equal to C times 1. You replace x for 1. Entonces es 1 and 1 plus 1 is 2 times 2. Entonces divided by 2 both sides. It's obvious that C is negative 5. And finally, x equal negative 1 is the other smart value. Because in that case, negative 1, 4 again, no? Because it doesn't matter. Get negative or positive when you square becomes positive. However, here, no. Because minus 1 is plus 1. Minus 13. This is 5. This is negative 8. It's obvious. Negative 8 is equal. So when you plug in negative 1, it's obvious that this is cancelled. It's obvious that this is cancelled. Because negative 1 plus positive 1 is 0, but this is stay. This is B times negative 1 times negative 1 minus 1. The negative 1 and negative 1 is negative 2. And negative 2 times negative 1 is positive 2. So actually it's 2B. Therefore, divided by 2 both sides, B is negative 4. And this is the answer. The answer is 13 over x minus 4 over x plus 1. It doesn't matter if you put a negative here or here, either way. And negative 5 over x minus 1. Okay, corresponding with the option D in the handout. You see option D. Yeah. Well, no. Okay, this is positive, no? B. It's positive or negative? It's negative, no? Negative 4 and negative 5. FB. Sorry, FB, no D. FB. That one. B. Any question? partial fraction decomposition. We're doing one more. I left for you the other. Can you try to do it by yourself? Okay. Okay, that page is the next. Okay. Okay, good. Okay, this is 80 minus 14x divided by x cubic minus 8x squared plus 16x. Unfortunately, this polynomial in the denominator is not already factorization. But it's easy, or relatively easy. You can see the really common factor is x, and you factor out. Sometimes the polynomial is given by in factored form. Sometimes no. When there is no, entonces you factor out. I don't care the factorization in the top. It's not important. The important is the factorization in the bottom, because they give me how many factors and what kind of factor, repeated, not repeated, complex. I finish the factorization? Of course, no. I have a trinomial. Entonces now, suppose que I have no idea, you open two parentheses, because normally the factorization for the trinomial contains two binomials, but in this case, look, the combination is 4 and 4. Because 4 times 4 is 16, and 4 plus 4 is 8, and negative both. Entonces they are identical. Therefore, we have in the case when it's repeated. So actually, you write like that: 80 minus 14x over x minus 4 squared. Boom. And we start. This is just the beginning. Now, okay. I discovered okay, the partial fraction decomposition for this problem is, okay, I copy x minus 4 squared is one factor, is x, and it's a repeated. So since it's repeated, you decreasing, you copy, for example, x minus 4 to the power 1 and x minus 4 to the power 2. So you have power 3, so you put 1, 2, 3. And this is ABC. This is the most important thing, so understand what kind of problem we are doing. This is case 2, when you have a real factor, but repeated, multiplicity. Okay, entonces the LCD es obvio que es x times x minus 4 squared. When you multiply everything by this, stay 80 minus 14x equal. Entonces 8 times the factor, get missing, que es x minus 4 squared plus b, and we have here x times 1x minus 4. Because obviously with x minus 4 cancel out with the 1 and stay x and x minus 4 one time plus cx, right? Again, you apply the smart value, suppose 0. 0 is good because when you create 0 here, that guy is gone. and that guy is gone and stay like this. Entonces 80 is equal 8 times something. 0 minus 4 squared. 0 minus 4 squared is negative 4, and negative 4 squared is 16. Therefore, A is 80 divided by 16, get 5. 5. Suppose another guy gets another smart is 0, 0 and 4, sorry. When you create 4 here, this guy is gone, and it stays C. Entonces 4, entonces 80 minus 14 times 4. Get 14 times 4 is 56. So 80 minus 56 is 24. S equal, well, I saw A is cancelled, B is cancelled, and C stay only 4C. Therefore, divided by 4 both sides, so the C is equal 6. And we have no more smart value. This is situation happen in the repetition factor. So you create another value, not necessarily smart, I call frame. Okay, obviously it's a nice value like a 1, negative 1, no too big. So you already in 1, entonces es, pero I take advantage que I know A and B, A and C, sorry. You need to find B. Entonces 80 minus 14. Okay, 80 minus 14 is 66, yeah. So 80 minus 14 is 66, yeah. Is equal. Entonces we have A que 5 times 1 minus 4 is negative 3, and negative 3 squared 9. And 9 times 5, 45, okay? 45. Plus B, que I have no idea who is B. Multiplication by 1, multiplication by 1 minus 4 is negative 3. Plus C, que is 6 times 1, because X is 1. So now the rest is so small with the 66 is equal 45. Minus 3B plus 6. Entonces 45 plus 6 is 51. Actually, it's 51 minus 3B. 66 minus 51 divided by negative 3 is B. And B is 66 minus 51 is 15. And 15 divided by negative 3 is negative 5. Negative 5. Entonces my final answer is 5 over x minus 5 over x minus 4 plus 6 x minus 4 squared is the partial fraction decomposition, and this corresponds with the option C. Any question? How do you feel in that part?
Professor, for the smart value, do we just usually stick with like a small range, or is it like, does it depend on like the problem?
No. You're using either value to say. I recommend using easy value 1, negative 1, no 1000, no, it's any arbitrary value. Entonces, you don't want to complicate your life with the big number. Bueno, entonces you're using obviously 1, negative 1. It's arbitrary, totally arbitrary. Remember, we have equation. Entonces now x is arbitrary, it's free, and you need to find ABC que satisfy this equation, ¿no? Entonces to complete the idea, well, in this case, you apply the frame value when you have only one, the last letter. A, you find A, you find C, and you need to find B. They are complicated cases in which you need to apply several frame value, so you get a system of equation. Including, suppose we have different letters A, B, C, D, E, and you find A and C using a smart value. And the rest of the letter, you select different frame value, for example, 1, -1, and 2, and you form a system of equation. But this is too complicated, too long. No complicated, it's long and consuming time. And the test, no. In the test, never I put an example like that. I put an example similar to the example I did here, right now. Clear?
Yes, thank you.
Okay, no problem. Let's move on to another topic. Okay, remember number 7 and number 8 is for you. Okay, I don't want to solve this. Okay, because the same. It's too long and do not apport any extra information. Okay, let's move on to the example 9. Example 9 is a non-linear system of equation. Non-linear. Entonces es x squared plus y squared equal 25, and x plus y equal -7. Two equations form a system. This system obviously is non-linear because the first equation is non-linear. The second, yes, the second is linear. So I take advantage when this situation happens. You take the linear, that's the easier. Linear is when the exponent is 1. You isolate one variable and substitution in the second equation is non-linear. Let's do it. For example, I propose you substitution, isolate, y. Y is equal -7 minus x. I take the second equation, solve for y, or solve for x, it doesn't matter. And now substitution this expression in the another equation here, over there. So you have x squared plus parenthesis -7 minus x squared equal 25. Okay, good. Entonces now, wow, I see something weird. I see too many negative. But it's obvious that when you have negative square become positive. And you understand that this is equivalent to this. Let me know if you don't understand. So you don't understand, I explain. I explain the proof of this. Don't say this. Okay, this is easier to understand because you have a common factor that is -1. A -1 squared is +1. Disappear. Okay. Now expand that. To expand that, well, is x squared. You need to know the famous formula. The famous formula when you expand binomial square is square the first plus twice, multiplication both, plus square the second. You see it's minus here, it's minus in the first side, and positive always in the second side. In our specific example, square the first is 49. Plus, because it's plus. Multiplication both and 2, so 14. Where come from 14? 2 times 7, x, plus x squared. So in this moment, I realize that we ending in quadratic equation. Therefore, quadratic equation, for solving any quadratic equation, you have to express it in standard form. In standard form, it's recommendable moving 25 to the other side, no? And right hand side is 0. Okay, ready. So this and this together is 2x squared plus 14x And 49 minus 25 is 24. Yeah, positive 24 equal to 0. Wow, I can see you can divide it by 2, this equation, because any coefficients are even number, right? This is x squared plus 7x plus 12 equal to 0. Wow, too easy equation. By factorization is possible doing. Not necessarily quadratic formula. The combination is 4 and 3, no? 4 and 3, 4 times 3 is 12, 4 plus 3 is 7, and plus plus. Entonces x plus 4 is equal to 0, indicate us que es negative 4. And x plus 3 equals 0 is negative 3. So we have two values that indicate that our system has two solutions. I need to find the y value. Entonces, the super fantastic, easy way is using that formula. So, suppose at x equals negative 4, plug it in here. Look, because y is isolated. You plug it in either equation, but no. I take the easier, of course. Entonces, y is equal minus 7 minus 4. Be careful with the sign, because the expression has the corresponding sign. However, the value has also sign. And double negative becomes positive. Entonces, negative 7 plus 4 is negative 3. Conclusion for that part. The famous point solution is negative 4, negative 3. Okay, this is the x value and this is the y value. Likewise, at x equal minus 3, y is equal minus 7 minus 3. Entonces, minus 7 plus 3, que es negative 4. And the point is minus 3, negative 4. Any question? Any question? No? No? Everyone understand very well? But I have more. Because when you're solving this, in order to make sure that everything is okay, I simulate in Desmos. Okay, let me show you. There you go. Off. Do you see Desmos?
Yes.
This is the question number 9 I did it before. Look. Question 1, question 2, and the intersecting point. Boom! Look at that. It's obvious that the first equation is the blue, is a circle, and the linear equation is green, and the intersection, let me make it zoom to see, wow, the famous point of solution I found before. Negative 4, negative 3, and negative 3, negative 4. Super fantastic. This is the fantastic way to verification and the thinking we're doing. The piece of paper, you check it. And if you want, why not? You send me in the test, in the written test. You are doing your computation in the piece of paper. You convert to electronic copy and PDF. Send me and attach if you want. Also, this is sketch and Desmos. I suppose that you know very well how we are doing this. Any question, guys? Any question? No problem. Switching to whiteboard again. Okay. Erase or no? Can erase?
Yes.
Next is also nonlinear. It's number 10, no? Number 10, yeah. Number 10, on the same page. Is y equal minus x squared plus 13. Okay, this is my first equation. Okay, so nonlinear, obviously, and x squared plus y squared equals 25. It's my second equation. Okay, but I take advantage. Okay, y is isolated. So now we can't, obviously, substitution this expression here. Okay, what is the idea? The idea is form a new equation that contains only one variable. In this case would be x. This is x state plus minus x squared plus 13 squared equal 25. Okay, let me try to fix this and this. It's minus x squared plus 25. Now, so in this case, well, you expand this. Remember the formula. The formula, well, this stays in green down, and the square refers is x to the 4th power, no? Positive. So minus x squared is positive x to the 4th power. It's logical, right? However, in the middle, no, in the middle is negative. See, at least one guy is negative. So it's minus 2 times what? 2 times 13 is 26 x squared plus square 13 is 169. 169. Entonces, I suppose que our equation ending in quadratic equation, or not actually quadratic equation, sino quadratic in front equation, minus 25 equals 0. I move 25 to the left. Okay, ready. So now organization. Organization is, I put a higher degree, okay, 4, it's a polynomial. We combine is 25 minus 25. Welcome from 25 is 1 minus 26 is minus 25 plus 169 minus 25 is 144 equal to 0. Well, in this case, you factorization that polynomial, or I don't know, see, using quadratic formula is possible. But okay, it's easy, or relatively easy. Is the factorization is, look, open two parentheses, is x squared, welcome from x squared is square root x to the 4th power, no? The square root x to the 4th power is x squared, no? And the combination in that case is 16 and 9. Why? Because 16 times 9 is 144, and somehow 16 plus 9 is 25, and negative. Everything is negative. I finish the factorization? Of course, no. Of course, no, because I see a difference of a square, the famous difference of a square, a squared minus b squared. The factorization is a plus b, a minus b. It's another formula, no? So the factorization, this guy, is you open now 4 parentheses, is x, the square root 16 is 4, plus or minus, doesn't matter the order, who is plus, who is minus, the square root 9 is 3, plus or minus. And we have 4 solutions. One solution is negative 4, another solution is positive 4, another solution is negative 3, and another solution is positive 2. And we expect in this problem 4 solutions, 4 points. I need to find the y value. Well, to find the y value, the easy way is substitution in the first equation because y is isolated, waiting for me to compute that. And suppose in this case, I recommend doing by couple. Look, this is actually, you can represent like that, plus or minus 4. And this is plus and minus 3. Why is important? Because when you square, look, suppose at x equal plus or minus 4. Substitution here, y alone is equal minus all right, let's see, okay. It's minus plus or minus 4, and when you square become positive, entonces 16, so actually is minus 16 plus 13, que es negative 3. We have two points. The points are 4 positive, comma, negative 3, and 4 positive, comma, negative 3. Sorry, and negative 4. Negative, because we have two values of the x, positive and negative, positive and negative, positive and negative. And we have one unique y value. Because regardless is positive or negative, the answer is negative 3. Likewise, at x equal plus or minus 3, y is equal minus plus or minus 3 squared plus 13. Entonces, negative 9, positive, and a positive, but we have a negative here, plus 13 is 4, positive 4. So we have 2 points. The point are the point 3, 4, and the point negative 3, 4. 4 solutions. Super clear or super confusing? Clear or no?
Clear.
Okay. Entonces, we have no problem with this because I double checking in Desmos. So Desmos is not the way to find the solution. So you for example, you solve the problem. You say, no, professor, I solved it because I saw in Desmos. No, you don't. Desmos is double check. Desmos is double check. You solve them by hand and double checking. See, the coincidences because I did well, no? Okay, so let's double checking in Desmos. Boom. Okay, that was a question 9. And the question 10 is, look, it's the question 10. And you graph it that. Look at that. The first equation represents the parabola, get the black one. Parabola can open down. And the y-intercept is 13. And the second equation is the red one. It's a circle. Center and the origin 0,0 and radius 5. And we saw clear like water. Okay, we have 4 solutions. Any question? No? Okay. Now let me see. This is the page number 2, no? Yeah. It's problem number 10. No? We finished that. So let's move on to the. Okay, do you see whiteboard or no? Not yet, no? You see this one now, eh?
Yeah, we still see decimals.
I need to switch into. Okay. Good. Come on. Okay, now the page 11. Well, let me switching to whiteboard. You see whiteboard now? Yes or no?
Yes.
Okay, what's going on? Okay, this is this page. Now. Okay, 11. Well, 11 is easy in my opinion because, look, the first equation is y equal 6x squared minus 5x. Okay, let me make zoom to see more clear. And the second equation is y is equal 2x plus 3. This is the system. Equation 1, equation 2. Don't expect, because the equation always is, you know, arrangement in elegant way. No. Sometimes it's easy in crazy way. Now, I take advantage of this fact because y is isolated in both equations. Therefore, this y and this y is the same, because my equation is reduced like that. 6x squared minus 5x is equal to x plus 3. Wow, fantastic, right? And this looks like quadratic equation, no? Let's move everything to the left. And we have 6x squared minus 5x minus 2x minus 3 equal 0. We combine later one more time. 6x squared minus 7x minus 3 equals 0. Okay, and you solving this quadratic equation, you can use a quadratic formula. But I prefer in this case because it's relatively easy, at least for me, factorization. You know, with the factorization, you multiply this number. 6 times 3 is 18. It doesn't matter the sign is not important. And try to find the combination. The combination is 9 and 2 because I know that 9 times 2 is 18 and somehow 9 minus 2 is 7. So you separate this 7 like a 9 and 2. So it's 6x squared minus 9x minus 2x minus 3 equals 0. So this equation is equivalent to the original, right? Because the only thing I did was separate 7 and negative 9 and positive 2, sorry. Right? Now factorization by grouping now. Grouping is this couple and this couple. Okay, this couple, the great common factor is 3x. It's obvious, right? And we have 2x minus 3. In the blue bar, the great common factor is 1. So we have no common factor. Oh, no, it's 1. Never is 1, is 1. 2x minus 3. And you see clear, okay, 2x minus 3 is a common factor. I factor out one more time. And we have 3x plus 1. Okay? They separate 2x minus 3 equals 0. That indicate us okay, 2x is equal to 3, therefore x is 3 half, 1.5. And 3x plus 1 equals 0. 3x equals negative 1, x negative 1/3. Negative 1/3. Negative 1/3. If you want to find the y associated with this, well, in substitution in either equation. Well, in my opinion, the easy way is substitution in the equation 2, get linear, right? Obviously. So y is equal. So let me organize very, very well this. Add x equals 3 over 2 substitution, and this y is equal to 2 times 3 over 2. I guess x replaced by 3 over 2 plus 3. Well, it's obvious that this 2 is cancelled. And let's take 3 plus 3 is 6. And the famous point is the point 3/2, comma 6. And the second is similar, is at x equal -1/3, y is equal to time -1/3 plus 3. This is -2/3 plus 3. For 3, que 3 is 3/1, no? It's a whole number. Entonces, the least common denominator is 3. We have -2 plus 9. Welcome from 9, 3 times 3. It's 7. 7/3. And the famous point is the point -1/3, comma 7/3. To solution in that case. Here's the option A. It's a little bit confusing. Let's say. No. Hello. Not here. Here. I don't know if you see well or not. You see well? You feel good? Guys, answer me. It's a little bit hard. Speak, and I have no answer. And this is a review. Those for me is extremely important. You understand very well. Okay. So far, you follow me or no?
Yes,
Hey,
so
yes.
far.
Okay. Who are you, Miss?
Isabella.
Isabella Crespo. I suppose Carlos always understand very well. Viviana Tinoco, yes. Okay, Yasmin, Bennett, wow. Juan. Okay. Okay, let's move on to the next. Next. What is that number? 11, no? 11, no, 12. Okay, number 12. 12 is same. 12 is in the same page. Yeah. In the same page. Okay, in 12 we have 3. Okay, let me try. Make it soon. We have 3 x squared. Too much. Okay, you have 3. Oh, better. X squared minus 3 y squared equals 36. This is my first nonlinear equation. And my second is 4x squared minus 5 y squared equals 84. This is a system. Both equations are nonlinear. What the situation happen? Never substitution. Never. Okay, I realize in the equation number 1 is there common factor, que es 3. So you can divide by 3, and when you divide by 3, we have a new equation that is easier, in my opinion, que is x squared minus y squared equal 12, no? Yeah, because 36 divided by 3 is 12. And this is equation 1, is equivalent to the original. Entonces I focus in the new equation 1 and the equation 2. If, for example, in order to by the way, I make a mistake here. This is plus and the original plus. Yeah, a plus. So I propose you, for example, there are many ways to do this. Multiplication by 5. this equation times 5. Well, my intention is to get positive 5 here, negative 5 is ready for elimination. Entonces 5 x squared minus 5 y squared is equal to 12 times 5 is 60. And this again is my equation number 1, okay, I modify 2 times. So I focus in this equation, Okay, you adding equation 1 plus equation 2, look, this and this, together is 9, x squared equal, entonces es 144, so 84, 60, 144, yeah. Divided by 9, both sides, is x squared equal 144 over 9. And apply square root because I need x, no x squared. Because x alone is plus or minus, square root of 144 is 12 over 3. Okay, 4, plus or minus 4. 2 solutions. Okay, not bad. Now substitution, and which one? And the easier equation always. I try to discover what is the easier equation. In my opinion, the easier equation is this equation. Look. Therefore, what should I do? Well, to say x squared is 4, but substitution both, plus or minus 4 squared. Here, minus y squared equal to this is 16, regardless if it's positive or negative, minus y squared equal 12. 16 minus 12 is equal y squared. Okay, 4, no? It's 4. It's equal y squared, and find the square root of both sides. So the y is equal to plus or minus 2. So we have 4 solutions because it's the combination positive 4 and positive 2. So basically, the 4 solutions we have in my hand is 4, 2, taking the positive and positive, and negative 4 and positive 2 again, why not? And positive 4 and negative 2, and negative 4 and negative 2. We have 4 solutions in that case. Get the option C in the handout. And let's check in this one now. Okay, let me see. We are doing question number 12. Yeah. Okay, yeah, absolutely. Let me check it. The simulation in this mosquita. Okay. Okay, and number 12, no? Number 12. Number 12, yeah. There you go, look at that. The first equation is a circle, so the green one. No, this is ellipse. And this is hyperbola. And the intersection in between both curve is 4 points. Good or not good?
Good.
Let's do one more of the nonlinear. This is important. Mm-hmm. Okay. The last one of the nonlinear is x squared plus y squared equal 9. This is my first equation. And my second is x squared minus y squared equal 9. Wow, same number. Sound weird. Well, it's ready for elimination. No? So you are in one equation plus two equations, something interesting happened because this is 2x squared. This is cancelled. It's gone. Equal 18. 9 plus 9 divided by 2. X squared is equal 9. And apply square root both sides, plus or minus 3. If, for example, you substitution this idea in the first equation, maybe, or in the second, either way, you have, look here, here, that equation. Suppose is plus or minus 3 x squared plus y squared equal 9. This is 9. Wow, entonces es obvio que y squared is 0. Therefore, y is 0. And we have 2 points. The point are 3, 0 and negative 3, 0. 2 points. That was easy. Very easy. Okay, what's that? 13, no? Yes. Okay, look at that. In decimals, let me verify. See, I do well now. Mm-hmm. 13. Look. Okay, 13 is, wow. It's a circle, red circle, and the hyperbola. And the only intersection in between this curve, the blue and the red, is 2 points. Okay, put in green color. 3,0 minus 3,0. Any question, guys? Any question? To say you get 100 points in this test or not? Was hard, this test.
It's
Everyone?
clear so far, the questions.
Okay. Then let's move on to the next questions. Okay, the next question, 14, 15, 16, 17, and even 18 are graphic. And the graphic always we are doing using decimals, okay? Let's move on to decimals if we solve them one by one. They want to explain, detail the organization in decimals of this. Okay. Okay, question 14 is a system of inequality, in this case linear. The first inequality is 4x plus 3y. Do you see very well decimal, right? Okay, I don't want to switching, not switching to the whiteboard, only decimals. You see, right? So we have two inequalities. The first one is 4x plus 3y greater than or equal to 12. And the second is x greater than or equal to y. And you put together in that way. So you open the curly bracket, and that indicates the operation and. So you are doing the inequality number 1, inequality number 2 separately, and intersection, que es the common what? Common region. Bam, and this look like that. Okay, you want to see separately, you can, but no, not necessary. Do you understand very well this or no? Come on.
Yes.
And you are practice by yourself doing that inequality at home? Well, for the test, yes, you have to practice, no? Okay, this is 14. So you, of course, don't show me anywhere. You only download this, no? So you click here, export, and this is a graph. You download that graphic, and that's it. Okay, and 15, well, 15 is non-linear. It's a circle, radio 10, and linear. Loop. Boom. Okay, it's inside the circle and below, sorry, below, because it's less than, below the line. Entonces, you know, it's one, not semicircle, but it's one portion of the circle. Inside the circle and below the line. And by the way, the line is solid line. And the curve of the circle is also solid, no dot. This is important detail. Everyone follow me? 16. Whoa, 16 is similar. It's a circle and the line. Similar, very similar. Very similar. Any questions so far? You understand very well?
Yes.
The 17 and 18 is a typical problem of the linear programming. And remember, linear programming we have, let me try to come back to the whiteboard to see this. Let me try. Okay, there you go. So that page I cover. Okay, that page I cover. That page I cover. That page no. This is the page we are talking about. Okay, so you understand very well the graphic of the question 16, no? It's 16. And the solution is that graph, see, no? Now, linear programming. Let's focus on linear programming. Linear programming, remember.
That's where we still see decimals.
Sorry. Okay. So let's do it. Let's prepare to solving 17 and 18 in decimals, no? Okay, now you have a typical linear programming problems. In the linear programming problems, we have a family of inequality that represent the constraints of the problem. For example, in the 17, the constraints are x and between 0 and 10, and y and between 0 and 5. And we have another line que es 3x plus 2y greater than or equal to 6. And that's it. This is the constraint. I put in decimals, and you see the region, the region que satisfy that condition, no? Entonces now, the region que satisfy that condition, you determine the corner of this polygon, because actually is something like that, no? In general, no exactly. In this case, it's a corner. We have 1, 2, 3, 4, and 5 corner. That corner is well, I don't remember. 1, 2, 3, 4, 5. Yeah, it's 0,5, 0,3. Okay, something like that. Well, okay. So you determine that corner. How? Graphically. And this is the region. Let me show you. Entonces, the optimum value, minimum or maximum, in this case, maximum. Okay, how do you know? Because you need to maximize, no? Maximum, determine the maximum value. This is important keyword. So now you plug it in any corner, you determine x and y. You plug it in where? Plug it in the objective function, okay, C. S equals 15, x plus 13, y. And you determine the maximum value. Okay. Let's do it, pero let's do it en decimals. Look. Okay, 17. You see decimal, right? No? Yeah, I got it. Okay, entonces, I did that. Look, this is a little bit weird. I don't know why exactly it don't allow me to do, but okay, I put two inequality. Okay, and suppose I delete that part. This is x between 0 and 10, and y between 0 and 5. It's obviously rectangular. And the other is a line, so it's above the line. And obviously, the intersecting is the part is overlap, the part you see dark. Actually, so we have pentagon, no? 1, 2, 3, 4, and 5 sides, and 5 vertex. And you determine, the most important is determine the vertex, no? This vertex is 0,5, this vertex is 0,3. This vertex is 2,0, and this is 10,0, and this is 10,5. And you plug in one by one that point in the objective function and determine the maximum value. Okay, this is important. Determine graphically the feasible region, okay, the region in which satisfy all inequality, or satisfy the system of inequality, and determine the corner, que es the potential optimum, and in order to select the optimum of the optimum, is the maximum, or minimum, depending on the problem, no? But in this case, maximum. Okay, so now you evaluate. For example, you evaluate dark corners. You evaluate dark corners. Okay, by the way, let me fix that. Okay, do you see whiteboard?
Yes.
I know a specific problem. This point is a point 0,5. This point is a point 0,3. This point is 0,2. You see more clear in this one, no? This point is 10,0, and this point is 10,5. and use substitution here. Suppose que I evaluate at C 0,5. 15 times 0 plus 13 times 5 is 65. So the objective function at that point is equal to 65. C en 0,3 is 15 times 0 plus 13 times 3 que es 39. Okay. Evaluate en 2, en 2,0. This is mistake. Es obvio, ¿no? Es on the x-axis, 2,0. Entonces, evaluate en 2,0 es 15 times 2 plus 13 times 0. Es obvio que es 30. Si evaluate en 10,0 es 15 times 10 plus 13 times 0 is 150. Oh, okay, increasing. It's obvious, right? Now, finally, in C 10,5 is 15 times 10 plus 13 times 5. This is 150, and this is 65, and the answer is 250. And it's the maximum. The answer is, look, the maximum occur, the maximum is equal to 15 is this answer. It occur at the point 10,5. Okay? So you need to make selection. Suppose que this obey to the word problem. You say, I don't know, you sell something, you sell a smartphone and you sell computer. X is a smartphone, Y is a computer. Then you need to get the maximum profit. Then how many cell phone you sell is 10, and how many computer 5. And what is the profit? And the profit is 215, maybe is $1,000. Make it is clear or no? Linear programming is clear? Linear programming, I repeat again the idea, consists in two pieces. The first piece is the constraints. And constraint is just the set of inequality. Okay, our physical problem or word problem obeyed. That means that inside the feasible region, que es the solution for the constraint, our problem have sense. And outside have no sense. This is stupid solution. Now you need to discover always the solution can have sense, you know. However, in order to find the optimum, you select the best, and the best is in that case maximum, not necessarily always, or minimum, depending on the problem. You know? See the feature that you analyze is good, you get maximum good. Maximum good is good, no? It's excellent. Minimum bad is also good, it's optimal, no? But in this case, no. In this case, everything is maximum. Let's move into decimal for solving 18. It's exactly the same. And we return to the decimals in order to see. Okay. Boom, boom, and boom. Okay. Let's go 17. 17 is history. No more 17. Now 19. Look at the 19. Wow. 19 is, we have 1, 2, 3, and 4 inequality. We connect them in that way. And form it, that polygon. This is the feasible region. They put it in green color. And this is the corner. The corner is, okay, let me see the corner. The corner is 0,0. 0,0, so this feasible region look like quadrilateral, and the vertex of that quadrilateral is 0,0, 0,4, 3,2, and 4,0. Okay. Okay. Do you understand very well how you write this system in Desmos? Yes or no? Okay. Any point outside the feasible region have no sense. Inside, yes. But the optimum occur in the vertex, in the corner. And you evaluate one by one in the objective function. Okay, the objective function is 6x plus 7y. It's doing. Okay. Okay, this is my famous one. Okay, the feasible region. Let me try to do my best. Look like, figure it like that. Okay. I'm using green color, no?
Professor, we still see that.
Ah, sorry. Sorry. I always forgot to switch it. Okay. Do you see now?
Yes.
Okay. So I try to do my best in the drawing. This is the feasible region now. Okay. This is x-axis. This is y-axis. And the point was 0,4. And that point was 3,2. The point is 0, of course. And that point is 4,0. And my objective function is 6x plus 7y. And you plug it in. And 0, is obvious 0. That one. And 0,4. And the y4 is 28, no? 0 times 6 is 0. 7 times 4 is 28. Evaluate in 3,2. Is, is 3 times 6, 18. Plus 2 times 7, 14. And this is 32. And C, evaluate in 4,0 is 4 times 6 is 24. Oh, nice. This is the maximum. Okay, the maximum is this option. Look. The maximum is 32 at 2,3 is that point. Super clear. Yes or no? Linear programming. Linear programming. Easy, right?
Yes.
I know. Okay, guys, the question 19 and 20 is very similar and two questions that we were doing before. It's super elementary. I want to skip that because the first one is back substitution, 19, and the second is very similar to another question that is inconsistent and you solve it exactly the same. So I want to skip 19 and 20. Just in case, if you want, let's do it and stop because we have time. So now we dedicate next day, so next week, next day, to the complicated part. Okay, the matrices, the algebra problem. So we are doing this and that's it. Okay, let me see this. No. Oh yeah, it's this page. It's this page. Okay. So my plan is today Thursday, no? Tuesday we finish. Entonces now I sent Tuesday the written test. I call it next Thursday. Okay? I don't remember very well what the due date for the online test. But I try to see it's not the same day. I try to match it this day. So our fantastic day is next Thursday. Okay, by the way, is 14. 7 plus 7. Today is 7. 14. So 14, April 14 is the due date for the test number 4. And we start the final test case a little bit easy. Okay, let's doing 19 and 20. Okay, super elementary problem. Look. And number 19 is obvious. Okay, you apply back substitution because there's, the system is some variable is missing, no? X plus 3y plus 2c equals 6. 5y plus 5z equal 15. Okay, if you want this equation 2, you can divide it by 5, no? And when you divide by 5, this guy is gone, and 15 divided by 5 is 3, no? It's another possibility to write this equation, no? You try to make it easy. And c is 5. 5. Equation 3. So actually, I have c value. In order to find the y value is y plus 5 equal 3. Y is equal 3 minus 5, okay, negative 2. So y is negative 2. And x is x plus 3 times negative 2, que es y, plus 2c, que is 2 times 5, is equal to 6. This is x minus 6 plus 10 equals 6. Entonces this is negative 6 and positive 4, no? X is equal to 6 minus 4, okay, 2. The solution is the triple order, no? Triple order 2, negative 2, 5. Oh, option A. You expect one easy problem like that in the test. Okay, you are doing using back substitution. Okay? And 20 is similar. 20 is similar to the one thing we are doing before. You prove case inconsistent. And the way to prove is because look at the equation. The first equation is x plus y plus equal negative 5. X minus y plus 3z equal negative 6. And the last equation is 2x plus 2y plus 2c equal negative 6. And you see some connection in between 1 and 3, no? You say, see, you divide by 2. In this case, it's divided by 2 because it's even, no? But see, it's 3, 3, 3 divided by 3. And you get x plus y plus c equal minus 3. Entonces, this equation, and this equation is a contradiction. Because the expression x plus y plus c is the same. It's equal to -5 and also it's equal to -3. This is a contradiction. Entonces, no solution. Inconsistent. Okay, inconsistent. Entonces, so far, stop here because I want to dedicate Tuesday to complicated part of the matrices. Not complicated, but you know, it's different to say I want to dedicate matrix Tuesdays. Tuesday I will send the reading test, and you have today to solve it and send to me by email. Correct? Everyone is clear? Everyone is clear? Clear or confusing?
Yeah.
Come on. Clear?
Yes, clear.
Clear.
Yes.
Stop. Bye-bye. Okay.
Bye,
Have a nice
Professor.
day. Bye-bye.